Bright Duty. Every student matters.
Hello dear students, today we will be studying about refraction of light. In the previous topics you have discussed about and learnt about reflection of light, but we will be considering refraction. Fine. Now, refraction of light. We know that light always travels in a straight line. Fine. This phenomena or this property of light is known as linear propagation of light. But when light passes from one medium to another medium to second medium, the light changes its direction. We have seen in our everyday life a lot many phenomena that confuse us as to how and why it happened. For example, we see that if we place a coin in a glass full of water, then that coin appears to be raised. We have seen that if we put a pencil or a pen in a glass of water, that appears to be bent. Why did that happen? It was all because of this particular word called refraction of light, and that is what we are going to study in this particular chapter. Before understanding it, we need to know that when we are talking about different media, plural of medium, then in different mediums the speed of light is different. We must know that the speed of light in air and vacuum is taken to be 3 into 10 to the power 8 meter per second. Actually, this is the speed of light in vacuum, and there is just a very slight variation in air. So we take same speed both as in air as well as in vacuum. But when light enters water, its speed changes and it becomes 2.25 into 10 to the power 8 meter per second. In glass, even though there are different types of glass, but as a whole, generalized, in glass the speed becomes 2 into 10 to the power 8 meter per second. Fine. Now, seemingly they appear to be very less differentiated, but actually when we see in bigger terms, like I can write this thing as 3 lakh kilometers per hour per second, sorry, and this speed in glass is 2 lakh kilometers per second. I am talking about a difference of 1 lakh kilometer per second. The same thing happens when light enters from one medium to another, because when it moves from one medium to another, then there is a huge sudden change and difference in the speed of light. Fine. This is what we will be studying in this particular chapter. Now, we have seen the speed of light in different media. When I compare two media, for example, I compare air and water, I see that the speed of light in air is more and the speed of light in water is less. So when I will compare two media, the medium in which the speed of light is more, that medium is known as optically rarer medium, whereas the medium in which speed of light is less, that medium is called optically denser medium. Now, one thing we need to remember is we cannot say that water is optically denser medium always. Two medium are when compared, only then we can relate out of these two which is optically rarer and which is optically denser. For example, as compared to air or let us say vacuum, now water is optically denser medium because speed of light in water is lesser as compared to the speed of light in air. But when I compare the speed of light in water and glass, now I can see that among water and glass, the speed of light is more in water and less in glass. Therefore, among these two media, water and glass, I'll say that in water the speed of light is more. So, water is optically rarer medium as compared to glass. So, you can differentiate very well. Over here water was denser medium. Fine. Over here water is rarer medium, just because we are comparing here it with air and here with glass. One quite important thing, when we are talking about denser medium and rarer medium, we are not actually talking about the mass density. I am not saying that this medium is thicker or denser. I am talking about optically rarer and optically denser. We are just relating it with the speed of light. So, we have a basic idea of optically rarer medium and optically denser medium, right? Now, to understand the phenomena of refraction of light through a glass slab, let us do an activity. For this, we require a soft drawing board, we require 4 sharp common pins, 2 white sheets of paper, we require a rectangular glass slab, a protractor, 4 drawing pins, will be requiring a meter scale and a pencil, right? So, let us see how exactly we are going to proceed with this activity. First of all, we will fix a white sheet of paper on the soft drawing board with the help of drawing pens. Now, place the rectangular glass slab in the middle of the white sheet of paper and draw its boundaries A, B, C, D with a sharp pencil. Now, remove the glass slab. Alright. On this side AB, mark a point E. Then draw a perpendicular and name it NM at point E. Now, NM is normal to the surface AB. With the help of a protractor now, we will make an angle of 30 degrees and we will name it angle PEN, right. This will be our angle of incidence, okay. Now, fix 2 pins P and Q on the line PE in an upright position by applying a gentle pressure with the help of thumb or forefinger, keeping distance between them about 5 centimeters, okay. Now, what we will do is, we will replace the glass block in its boundary ABCD and looking through side CD, we will locate the image of the pins P and Q, which will appear at P1 and Q1 respectively. And why is it so? Because of refraction. Alright. So, we will just look at the images of pin P and Q and fix 2 more pins R and S in upright position by keeping eye at a distance of 30 centimeters from the nearest point, such that these pins and the images of pin P and Q are in the same straight line. Now, remove the pins PQRS one by one and draw small circles around the points with the help of sharp pencil. Again, remove the glass slab. Joining points R and S by a straight line in such a way that line meets CD at F, join EF, draw a normal at point F on the straight line CD. As you can see, measure the angle of incidence and angle of emergence in whole numbers only. Okay, so you will get to know these measurements. Now, repeat the experiment for angles of incidences as 40 degree, 50 degree and 60 degree, and in each case measure and record the angle of emergence. Okay. Now, when you will perform this experiment, you will conclude that as the difference between the angle of incidence and angle of emergence is within the experimental limits, that is plus minus 1 degree, therefore, angle of incidence is equivalent to angle of emergence, which says that incident ray is parallel to the emergent ray. Now, the angle of refraction is less than the angle of incidence when the rays of light travel from the rarer to the denser medium. With the increase in the angle of incidence, the angle of refraction is also increasing. And this is happening in such a way that every time you take the sine of angle of incidence, sine of angle of refraction, and you will calculate the refractive index of glass with respect to air with the formula, the ratio between sine of angle of incidences to the sine of angle of refraction, we will find that it is nearly constant or fixed. Okay. When we put a coin in a glass of water, it appears to be raised. Why it happens? Let's do an activity, and for this we require an empty china mug, right? And we'll be requiring a coin as per your wish, 1 rupee, 2 rupee, 5 rupee coin, anything, and a beaker containing water. So let us proceed with the activity. How come? What we'll do is, first of all, we'll take an empty china mug and place a coin at its bottom. Okay. So after placing it, we'll observe the coin. We can see the coin, right? Then move backward slowly such that the coin is not visible at the line of sight, is obstructed by the edge of the cup. Now ask one of your friend or any person to pour water in the mug without disturbing the coin till the mug is half full. Now surprisingly you are able to see the coin. Now why exactly this is happening? Why the coin is appearing to be raised? Because the rays coming from the coin and travelling through water on emerging out in air, they basically change their direction. And why this direction was changed? This direction was changed because of the change in medium. Therefore, now it comes in your line of sight and you could see the coin, right? So this is the reason why we can see the coin raised above. Okay. So after doing this activity, we can very well relate that the coin which was at position A appears at position B now. In other words, B is the position of image of the coin A, and hence to the coin, for you the coin appears to be raised. Thus, to conclude, we can say that light bends from its path when it goes from one medium to another, and in this case the medium was water and the light ray was going from water to air. The same process you must have done with the case of the pencil appearing bent. Similarly, when the light rays from the coin at position A, they went from water to air, they bent away from the normal, and because of that these light rays coming or entering our eyes, because of linear propagation, we saw the image at B, and hence the coin appears to be raised. Okay. Now students, let us see this particular phenomena of refraction of light in certain common day-to-day observations, right? We will be doing an activity to show how a pencil appears bent and short when immersed in water. The materials that you will be requiring for this is a pencil. We will be taking a pencil and we will be just taking water contained in a beaker. Now let us see how we are going to proceed. What we will do is, we will take a pencil and immerse it partially in water contained in a beaker such that the pencil is held obliquely. Now observe the part of the pencil immersed in water. What you will observe is that the part of the pencil immersed in water appears displaced. Displaced means it should have been the position B and A, but to us it will appear to be B and A1. This suggests that light which is reaching our eye is refracted, and in simple way we can say that light bends from its path while travelling from air to water or vice versa. Why it happened? It happened because there are two different mediums in which the speed of light was different, and we saw that when light was travelling from water to air, water is basically optically denser medium as compared to air, which is optically rarer. So when the ray of light will go from water to air, it will bend away from the normal, and this bending light rays, they are reaching our eyes, and because of linear propagation of light, our eyes are going to form the image in the straight line from where the light rays were coming, and hence we saw the image of the pencil tip that was in the water to be at A1 position, right. So I hope you have understood how exactly this refraction causes some changes in vision and some common observations in our day-to-day life. Another observation from our day-to-day life is कि when we put a lemon, in glass of water, if we look from the sides, then we will see it appears to be bigger. Same reason, same reason, because of refraction, correct. You must have visited swimming pools. Now, it is a normal phenomena that the swimming pools appear to be less deep than they actually are. Let us see. This is the actual depth of the swimming pool. Fine. The ray of light which are going from this actual bottom, when they go from water to air, again they will bend away from the normal. When we will extend these, the image will be formed here. So for us, the apparent depth, the depth which will be visible to us will be this, and the actual depth was this. So there is a difference between it, and we say that the swimming pools are deeper than what they actually appear to be. So these are all based on the phenomena of refraction of light. Got it?